Welcome to Finance in Excel video number 46. Hey, if you want to download this Excel workbook for Chapter 6 or the PDF file for Chapter 6, click on the link directly below the video and scroll way down to the Finance class section. Oh wow, we have an exciting topic for this video and for the next 5 or 6 videos. Bonds. What is a bond? You got to just think of it as simply one thing. It is a loan contract. And anytime there's a loan contract, one side has a liability, other side has an asset. The person doing the borrowing has a liability. The person loaning the money has an asset. But you got to just think of a bond as a set of future cash flows. That's all it is. And what are the cash flows, right? You got to pay interest. I mean, the person doing the borrowing's got to pay interest back, and they have to pay the full loan amount back at the end of on the maturity date, right? Now, just a set of future cash flows. We're going to look at it from the borrower's point of view. We're going to start off our conversation just looking at cash flows, actually a cash flow diagram for the borrower and for the lender, because that's the way you want to think of this, right? Sometimes people get really confused in accounting and finance classes when it comes to bonds. But if you start off and just say, it's just a set of cash flows, that'll be helpful for our later more complicated calculations. All right, borrower. This person is called the bond issuer. So like a government or a corporation, right? Corporation or government issues some debt, liability, bond, whatever you want to call it. They are also called the bond seller. Here's how the cash flows might look for an interest-only loan. Or we're not going to call it an interest-only anymore. We're going to call it coupon. Coupon just means interest. Like in the olden days, you had a bond and you tear off this little coupon, and that would give you the right to get the interest payment. But here it is. Here's our cash flow diagrams that we've been using for the last 2 chapters. If this is from the point of view of the borrower, there's a minus 50, which means, let me blow this up. This payment, this payment, this payment, this payment, this payment. Those are all the interest payments or coupons. And at the end, they have one final cash flow out, which is paying back the original amount. But the problem is when you issue the loan, you very rarely, if the loan contract says I'm going to borrow 1,000, you very rarely get 1,000, and we'll talk about why later in this video, in fact. But just realize this is just cash flows. All these cash flows out over time, and this is the amount that the corporation or government gets right now, the amount they get to take in and then use for whatever they want. Now again, bonds, they're going to pay some rate. In this case, they're paying 10% in this example, right? But they're going to use the money and hopefully earn 15 or 20%, right? All right, this is an interest only, but there's a second kind. Well, there's many, lots of different kinds. So the main 2 kinds we're going to talk about is a coupon bond and a deep discount bond, or a zero coupon. If it's zero coupon is the name of it, it means there are no interest payments, no periodic interest payments. Does that mean there's no interest? No way. It's just that all of the interest and the amount borrowed, the face value, the principal, is paid back at the end. So it's called a deep discount and we saw this last chapter, we saw an amortization table for this, and we'll do it again this chapter. At the end, we're going to pay back 1,000, so that means coming into the corporation is this amount right here. So again, just think of it as a series of cash flows. In this example, they're going to pay out 1,000, and they get this much to borrow today. Now let's look at that same set of cash flows from the lender. Now the lender is the bondholder, right? This is the person that gives the money to the corporation, right? So they also called a bond buyer. They're going to record it on their books as an asset. The bondholder is buying a set of future cash flows. So for the interest only, same exact diagram as we just saw for the corporation, but this is the bondholder. So these are positive. These are our coupon payments. And notice it fits the pattern of an annuity, right? Equal time between each cash flow, equal cash flow amount each time. And at the end, you get the $1,000, which is written into the contract as the borrowed amount, or what we will call face value, and then all these coupon payments. All right, and then that means you pay this amount. This is what you are willing to pay given for these future cash flows. Deep discount or zero coupon bond, because there's no little coupons, no interest payments, at least no periodic interest payments. All of the principal and interest is paid back at the end. So if you are the bond holder, you're willing to pay $725.25 to receive $1,000 in 6 periods. Now, in this example, we'll do all the math for this coming up later. These are actually semi-annual periods. Now, we need to talk about bond terms. And actually, we did examples of both of these in last chapter. Remember, last chapter, chapter 5, was just multiple cash flow and how we calculate future value, present value, how to calculate the payment, the rate, and the number of periods. But we did all this, multiple cash flows. But we're going to use some different terms in this chapter, bond terms. So a bond is just a loan contract issued by a corporation or government that can be bought or sold in the financial market. So that's another big conceptual jump when you're learning finance like this. A bond, usually, unlike a loan for a bank, a loan, when you go out and take a loan at a bank, is usually harder to sell, right? But government bonds especially, you can just go out and sell them in the financial markets, right? So that's what a bond is. Loan contract, and can be bought or sold at any time. Coupon rate. We already know coupon rate. That's the APR. This is the contract interest rate for calculating interest payments. Now, this is going to be very important. We're going to have lots of bond examples in this chapter, and they're always going to say, hey, the interest rate for calculating the coupons or the payments is called the coupon rate. But there's something different in this chapter. We're actually going to have 2 different rates. Just don't forget, if coupon means the interest payment, coupon rate means the rate multiplied by the face value, and that'll give us how much each interest payment is. All right, but this one's different. Yield to market. Yield to market. This is the rate we use to discount our future cash flows. The market rate. Market rate is rate for similar securities. So if you are a corporation, you would look out there at similar corporations and look at what their rates are, right? I have a slide. Ooh, that's typed. Similar credit ratings, business activities, capital structures. You can look at that if you want. But you go out and if you're going to issue a bond, the rate that we discount the future cash flows at is market rate or yield to market, and it's a rate for similar securities. These are almost always going to be different. All right, so that's our first experience with 2 different rates for one financial instrument. The face value, we used to call this principal or future value amount. This is the amount of loan to pay back at maturity, right? This is in the contract. It says the loan amount is, and it's almost always $1,000, right? And this, and if a corporation wants more than $1,000, so if each bond is $1,000. They have to issue many bonds to get however much they want. All right, so it's going to be called face value. That's what I'm going to call it most of the time. It's also called par value or the principal. Coupon payment means that's the interest payment. That's the PMT. That's the periodic equal amount interest payment. Years to maturity. Now, in last chapter, we just said, hey, we're going to put some money in the bank and it's going to sit there for 10 years. But we have a different term here. Years to maturity. Now, when you first issue the bond and it says 10 years on the contract, then years to maturity is 10 years. But if the person that has the bond sells it 5 years later, how many years are left until maturity? 5. So this is years until payback face value and last coupon payment. Maturity, specific date when the face value and the last coupon payment is paid. So those are some terms we're going to use for this chapter. Now, what are our formulas? Well, we've already seen this formula here. Now, there's 2 parts. And the reason there's 2 parts is because when you value a bond, and this formula is specifically for a coupon bond value, but actually it works for zero and coupon, we've seen both of these. This is the present value of an annuity. Oh, there's our interest payments and present value of the future value amount. So one lump sum, an annuity pattern for interest payments. You do both of these calculations, add them together, and boom, you get the value of the bond. Now for Excel, we use the present value function, rate, NPER, PMT, FE. This is from the point of view of the bondholder, right? Because PMT, that's the interest positive into your pocket, and future value, that's the face value written on in the contract amount that's paid back at the end. Now over here, if you print this out, I explicitly have all the calculations right in there that you'd use for the present value function. Now here we go. Here's our math terms that we've used all the way through the last couple chapters, the bond terms in Excel. So from now on, the face value, that's the amount of the loan written in the contract. The bond value, that's always the present value of future cash flows. Yield to market, this is going to be our market rate that we use for discounting future cash flows. And that's our number of compounding periods. Almost all of the examples we're going to do are 2 semi-annual. Bonds are often semi-annual. Even the coupon bond, we use n equals 2 to calculate the interest even though it's not paid, and we'll talk more about that later. X, that's years until maturity. Total number of periods, we've been doing n times x. That's our NPER. Period rate, this is our rate in our functions, our financial functions. It's always going to be yield to market divided by n. This is the discount rate or the market rate or the yield to market. But this is the period rate. We have to divide it by n. Don't get confused. In earlier chapters, we always had an annual rate, and we used it for interest payments and for discounting future cash flows. But now that's not the case. This calculation is done with the yield to market. And then the PMT, that's where we take our coupon rate divided by n times the face value. And that gives us our interest payment. These have stars because in the past we had the same rate that we used in both of these, but now yield to market is what we're going to use for period rate or the rate argument in our financial functions, and coupon rate divided by n times face value is what we do for PMT. Our zero coupon, we saw just a moment ago, deep discount. This is a bond that makes no coupon payments and thus is initially priced at a deep discount. From the borrower's point of view, borrow an amount today, then pay back principal and all interest at the end of the loan period. From the lender's point of view, it's just the opposite, right? Bondholders lend, that's pay an amount today and receive all principal interest at the end of the period. So here's our zero bond value, our formula, and our PV function. This is from the point of view of the bondholder because that future value amount, the face value, is a positive. Now notice this formula, if we had just used this one, it would have been fine because this would be 0, and that would cancel that out. Zeros, we'll see this later. Even though there's no actual interest payments being made, no periodic interest, you still have to actually calculate them. And those interests, those calculations are deductible for income taxes for the bond issuer and taxable for income taxes for the bond holder. All right, here's some more functions. I'll let you look through these. We will do these throughout this chapter. We're going to use rate when we're solving for yield to market. We'll use effect when we want the effective annual yield. And when we're solving for the periodic coupon payments, we'll use the PMT. All right, now let's go back and look at this picture here, because now we got to get the heart of. We're going to do this one. OK, so on page 9, here's our cash flows. This is from the corporation's point of view. Oh, we have to pay out these interests. They're all negative, and then here's a negative. Why in the world are we only receiving $975? Usually when you go out and get a loan, you say, can I borrow $1,000, right? Because the face value is 1,000 here, and they give you 1,000. But they gave us less. So we got to see why that is. That's a lot of slides. There we go. So the bottom line is for coupon bonds, how come the bond issuer got $975 instead of $1,000? And the reason is very simple, because corporate and government bonds are bought and sold in the financial markets, and market rates change all the time. Rates are changing all the time because of new information, right? This means that the interest rate written in the bond contract, that's our coupon rate, is usually different from the interest rate in the financial markets. Now here's a picture. The picture says 1,000 words, right? Here's the corporation and the investment bank. And here's the contract. That's our information we're going to be using for our example for the next couple examples. So they write up, and look at this time scale. This times 0 is when we issue the bond contract, right? This is the day we issue the security. Security is a word used for stocks and bonds, a financial instrument backed by some asset. So the security is sold at time 0. But what happens before? Well, they're writing up. They're writing up their contract. And guess what? On the day, 4 months, 3 months, or whatever, even if they wrote it up one day before, on that day, they actually try to find the yield to market and write it into the contract. So in this example we're going to do, we wrote a coupon rate of 10%. Well, on the day that they wrote this contract, the yield to market and the coupon rate were almost assuredly exactly the same, right? But the problem is when you write a contract, right, it takes a while before you issue these securities. And so time passes, and this is the market, so rates change. So for example, on the day they sell the bond contract, the interest rates have changed. The coupon, this is the contract rate. So this is a contract that you're selling, right? 10%. But the yield to market is 11. Over here, if you sell, since bonds can be bought and sold, it can be totally different over here. So here's minus 4 months. Let's just say we wrote up, and coupon rate was 10, yield to market was 10. On the day we sold it, coupon rate was 10%. That determined the cash flows, but those cash flows are discounted at 11%. Then let's say, and this is our example we're going to do. This is the time line for our example. The bond holder bought the bond, but at period 4, which is year 2, because these are semi-annual periods, there's 1 year left, and they decide to sell the contract, right? So the day the bond is bought by a new person, the coupon rate is 10. Oh, but now the yield to market is 9%. Okay, so why do rates change? As we mentioned before, in financial markets each day, new information about the economy, the business, causes people to change their rates. All right, let's look at the math, and then we'll go over to Excel. This picture here has our information, our timeline for our cash flows, and our calculations. So here it is. It's the same one we did before. The only bit of information we need to look at here is the coupon rate is 10% when the contract was written, but by the time we got it to market, it's 11% yield to market. So here are our cash flows. We're going to do our present value of future lump sum, present value of an annuity of a coupon of all the coupons, right? There's our math symbols. There we plug in our numbers. We make our calculations. We add them together. In Excel, we do our arguments. There they all are there. We plug them in, and we get this amount. This is from the point of view, this is a coupon bond from the point of view of the corporation, right? So these cash flows that we put in, minus 50 and minus 1,000, are going to give us a present value of a positive, because that's the amount of money that comes into the corporation. Now, corporations do usually issue a face value of $1,000, but if they need, lots of money, they issue lots of bonds. Now, before we jump over to Excel, we're going to look at the exact same bond, but now we're going to look at a 0 coupon, right? And this is 0 coupon for the issuer, the bond issuer. This is the corporation. Same exact numbers. We have a yield to market of 11 and 10 here. Here's our cash flows. No coupon payments. Simply one cash flow at the end. We have to solve for the present value of this. There's our formula. There's our numbers plugged in. 1 plus yield to market raised to the 6 periods. That gives us $725. So for a deep discount or zero coupon, the corporation receives $725. When we get to Excel, we're just going to have one cash flow, that negative. This is from the corporation's point of view, so that's going out, that's paying it back, and then we'll get $725. Now let's go over to Excel. All right, so I'm going to blow this up. Interest only coupon bond. There's the bond issue date. There's our future value. That's $1,000 coming out, 10% coupon. NX. Let's calculate our period rate. Equals the coupon. This is for the coupon payment. Notice we're going to have separate calculations for our discounting rate, right? Divided by that. Our total number of periods equals n times years. So we have 6 periods. Now we can calculate our coupon, our PMT or coupon. Equals, hey, just take the face value. Now I'm going to actually put equals minus. Actually, I'm sorry. Equals this because it's a cash flow. That minus 1,000 will multiply that times our period rate, and that tells us every 6 months we're going to pay out, from the corporation's point of view, $50. Now, the yield to market is that, so we say equals this, and we have to do our period rate, right? Because we're discounting all these cash. That's the annuity right there. Now, luckily in Excel, we have one function. We don't have to do a big complicated calculation. Present value. Our rate, what is that going to be? That's our yield to market. That's the period yield to market. NPER, all the periods, because this is the beginning when the loan is issued. Our PMT, it is negative. Our future value, it is negative. The type is end. By default, it assumes it's end, so we leave it out, and then enter. $970. Now, I'm going to do it the long way just for, this one time. The rest of the times I will not do this. Okay, so we have to do our present value of an annuity. So I'm going to say the PMT. And I'm going to have to put a negative here. Times in parentheses, and I think it's a 1, 2, 3. I'm going to start with 2. Now this is present value of an annuity, so it's 1 minus, and then open parentheses 1 plus our period rate, YTM, caret, and then negative exponent 6. I'm going to close parenthesis on that. That's the green one. Now I divide by the period rate, yield to market. Finally, I close parentheses and Control Enter. That gives me just the part, and actually I think I will do it down. That's just the present value of those $50 cash flows. Let me do this next part down here. Present value, and it's going to be rate. I'm sorry, equals the future value. I'm going to do a negative, just get rid of that, and then divide by 1 plus our yield to market, caret our total number of periods. Now, the order of operations will calculate this first in the denominator, so that's fine. Now, when I add these up, if I go, actually, watch it. Here's a great trick. If I add these two together and come down to the status bar here, you can see sum 97502, so that works just fine. Now, I'm going to put this into edit mode and scoop this out. I'm going to highlight it, copy, escape, delete, click here, F2, and then plus. Actually, I think I have a minus there, so I can just go Control V. And there you go. That's the long way. Okay, now what about from the point of view of the bondholder for a 0? Easy calculation. We just do our equals PV, present value. The rate we're going to use is the period rate, comma, the NPR is 6. The PMT, there are none. So we skip it, type a comma, and then the future value is negative, and ding, 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 it'll give us 725. The long way, we take the future value amount and discount it, which means divide by 1 plus period rate, close parentheses, caret 6. F2, and I'm going to put a negative there to convert that. All right, so that's our first example of bond valuation using two different rates. We had a coupon rate right here and a yield to market divided by 1. That's the discount rate. We did it for a coupon, and then we did it for a 0. Now, before we end this video, I actually want to do the same exact example here, but from the bondholder point of view. So I'm going to come back to the PDFs. And when you're learning this stuff, it does help to see both sides of the coin, right? These are the same exact details, but we're going to do it for the bondholder. So the only difference is, the signs on the cash flow coming into your pocket if you buy the bond. Those are all plus 50 bucks. Those are our coupons or our PMTs, our future value or face value amount. Here's how we do it in Excel, which we'll go do in just a second. So we're going to get minus 975. And then the 0, same exact thing, except for look, the cash flow is positive here. That means when we solve for our PV, it's going to be negative. This is how much we pay. So for these two examples, this amount, minus $975.02, this is the amount the bondholder is willing to pay for this set of future cash flows. Same with here. That's why it comes up negative, because this is out of our pocket. This is how much we're willing to pay for that future cash flow. Now let's go over. And watch this. I'm going to do a little trick. I'm going to copy this right here. Control C. Those are formulas with relative cell references. So when I paste them there, boom. And notice, this one works just fine here, just like it did over here, because our cash flow is positive here, right? This is an amount coming in to the bondholder's pocket. This 50 for a coupon bond is coming in. Yield to market. Actually, I could do the same thing, right? Control C, Control V. Our present value equals PV. There's our period rate. Don't forget, when you're discounting cash flows, it's yield to market. NPER, PMT, it is positive. We like that interest coming into our pocket. Future value, that is positive, and enter. It's negative only because the cash flows are opposite. This is the amount this bondholder is willing to pay for these future cash flows. Down here, same exact details. This is just positive instead of negative because that's coming into the bondholder's pocket. So the rate, that period rate, NPER, comma to skip it, a future value, and there we have it, minus 725. They're willing to pay that much for that set of future cash flows. All right, that's our first video about bonds. When we come back, we'll look at what happens when the bondholder who initially bought it sells it, and the discount rate will be below the coupon rate, and we'll see what happens to the price. All right, we'll see you next video.